Okay, so we're going to finish our graphing radical functions worksheet. This is the third page. We're on number 10. So for number 10, we have f of x is equal to negative square root of x minus 2 plus 3. So if you think to the parent function of a square root function, which is f of x is equal to the square root of x, you can see the transformations here. So first, it is a reflection across the x-axis. Next, we have a shift right 2 units, and then a shift up 3 units, right? So you can either graph by using the transformations by just thinking, okay, so every point from the parent function would reflect across the x-axis and move right 2 units and up 3 units, right? So normally ours on the parent function, we start there, so that's going to move 2 units to the right and 3 units up right here, right? So that's our new starting point, and we know that because that's our end point. And if you remember back on the first page, the end point is HK, and HK here is 2, 3, right? This point right here is 2, 3. So we can write that in here as our endpoint, 2, 3. Next, you want to figure out. Now, if you're going to do this without a graphing calculator, I would recommend using a graphing calculator and using the table function, because it just saves you a lot of time when you're looking at the points where you have whole numbers. However, if, let's say you don't have a graphing calculator, or you don't want to use one, what you have to do is you have to make your radicand be perfect squares. So remember, we had the perfect squares, 1, 4, 9, 16. 16 is too far because you don't want to have an x value of 16. So with your radicands here, you want to, so first I want to make it 0. This is the point where I would be at if I made my radicand equal to 0. And so next I want my radicand to be equal to 1, right? That's another perfect square. So in order for me to make that equal to 1, I'm going to take 1 and I'm going to add 2 to it, right? That would give me 3. So if I plug in 3 into this function, I would have 3 minus 2, which is negative square root of 1 plus 3, right? I know that the square root of 1 is 1, so this is just negative 1 plus 3, which is equal to 2, right? So the reason you want to get your radicand to be the perfect squares is because you'll get whole numbers at the end now. So when I plug in 3 into this function, I get an output of 2. So I can graph that at 3, 2 right here. Next, you'll want to make your radicand 4. So since we're subtracting 4, I'm going to plug in 6, right? 4 plus 2 is 6, which is 6 minus 2 is 4, right? So negative, let me write my XY table over here. So we had 2, 3, then we had 3, 2. Now we're plugging in 6. So negative square root of 4 plus 3. Square root of 4 is 2, right? So this is negative 2 plus 3, which is equal to negative 1. So we can go ahead and graph that point. 6, negative 1. So that point is right here. And then what you want to do is you can just connect your points. And your graph is going to look something like this, right? So now we can discuss some of the end behaviors, and for those end behavior or the characteristics of this graph. So first we can talk about the domain. So remember, the domain refers to all our x values that we can plug into this function, all our inputs. So we can't plug in anything less than 2, right? for x, because if we plug in anything less than 2, we're going to get a negative number. We can't have a negative radicand, right, in this function because it is a square root function. We can't take the square root of a negative number. So all of our x values have to be 2 or greater. So then that means that our domain is x is greater than or equal to 2. Right? If you were to plug in 1, you would get -1 as a radicand. When you plug in 2, you get 0 as a radicand, and that's okay. Next, we have the range. So when we're discussing the range, we want to look at the y values, right? So the highest y value that we can get is at y equals 3, right? Because we're not getting any y values above 3. All our y values are going down because we have a decreasing interval here. It's a reflection across the x-axis, so we're going to have a decreasing interval. So that means that for our y values, we're only going to get numbers starting at 3 and then lower. So that means that our range is y is less than or equal to 3. Right? Y is 3 here, y is 2 here, y is -1. They'll continue to get smaller or lower numbers. Next, so our end behaviors. So we're always talking about as x approaches infinity, right? So as x is approaching infinity, our y values or our output is approaching negative infinity, right? Because as x increases, y is decreasing, and it's happening infinitely. So that means that as x approaches infinity, our output approaches negative infinity. Next, we want to be going from infinity to the left, and remember, it's not going to go to negative infinity because we can't have negative numbers in here, and we have a limit. Our domain tells us we have a limit of x values, so we're going to say as x approaches that limit, and that limit on the x-axis is 2. So as x approaches 2, our output, right? So as x is approaching 2, our output, meaning our y value, is approaching 3. Next, we don't have an increasing interval this time, right? But we have a decreasing interval, and our decreasing interval is this whole graph. It's start, and with a decreasing interval, we're stating where it's decrease, like where the decrease starts, and it's referring to the x value, or on the x-axis where it starts to decrease, right? So our graph starts to decrease here, which is at x equals 2. And it decreases all the way into infinity, right? All right, so for these next few, if you're going to be doing it without a graphing calculator, now we're doing a cube root, right? So with the cube root, you want to think of the perfect cubes, which is going to be 1, 8. The next one is 27. You're not going to be able to graph that because that's going to go way out of your x-axis, so we're just going to focus on 1 and 8, but also -1 and -8, right? Because you can take the cube root of a negative number. So I'm going to show you guys how to graph this one without the graphing calculator, and then the last two we'll do on the graphing calculator because I recommend that you use that. It's going to be a lot quicker, but I also want you guys to understand how to do it without the graphing calculator. So first, let's think about this function. So if you think about the parent function of a cube root function, it's f of x is equal to the cube root of x. And we can see the transformations here, right? So it's shifting to the left 3 units, and it's shifting up 2 units, right? So it's going to be shifting up from the parent function. And if you remember, hk is our turning point. So we can graph that point, right? Remember, so h is always the opposite of number inside of the radical. So h is -3. And this is 2, right? This is our turning point. Just want to write that there so you guys can see. So that's our turning point. So I'm going to graph that. It's at -3, 2. So 1, 2, 3, 1, 2 right here. And next, we want to graph points that are going to be whole numbers, right? And the way that you're going to do that is you want to make your radicand equal to these numbers right here, right? You want to make them perfect cubes so that you can get a whole number when you take the cube root. So first, let's start off with, and let me put this point right here. This was -3, 2. So first, let's start with the negatives, right? or we can, actually, let's just start with the positives. So I want to make this radicand equal to 1, right? So since we're adding 3, I'm going to subtract 3 from 1, right? 1 minus 3 is equal to negative 2. So that means that if I plug in negative 2 for x, I'm going to get 1, right? So I'm replacing x with negative 2. Negative 2 plus 3 is positive 1, right? So this becomes the cube root of 1 plus 2. And the cube root of 1 is 1. 1 plus 2 is 3. So when x is negative 2, our output, or y value, is going to be 3. So we can go ahead and graph that point. So that's where our point is at. Next, we want to make our radicand equal to 8, right? So since we're adding 3, we're going to subtract 3 from 8. 8 minus 3 is 5. So that means if I plug in 5 for x, we're going to get a radicand of 8. So we're going to plug in 5 here. So 5 plus 3 is 8. So we have the cube root of 8 plus 2. We know that the cube root of 8 is 2. So this is 2 plus 2, which is equal to 4. So when I plug in 5, my output is 4. So let's go ahead and graph that point. 1, 2, 3, 4, 5. 1, 2, 3, 4. So that point will be right here. All right, so now that we have positive 1 and positive 8, let's make this negative 1 and negative 8. So since we're adding 3, I want to subtract 3 from negative 1, right? Negative 1 minus 3 is negative 4. So that means that if I plug in negative 4 in for x, I'm going to get negative 1, right? So let's do it. Negative 4. Negative 4 plus 3 is negative 1. So this is the cube root of negative 1 plus 2. The cube root of negative 1 is negative 1. And negative 1 plus 2 is equal to just 1, right? So when I plug in negative 4 into this function, I'm going to get 1. So 1, 2, 3, 4, and 1. So that point's right here. Next, I want to make my radicand negative 8, right? So I'm going to subtract 3 from 8, which gives me negative 11. So if I plug in negative 11 here, I'm going to get negative 8, right? Negative 11 plus 3. This becomes the cube root of negative 8 plus 2. And then the cube root of negative 8 is negative 2. Negative 2 plus 2 is equal to 0. So our point is at negative 11, 0. Negative 11 goes right outside right here. So I'm just going to graph it right around here because it goes outside of our graph. But now we can connect our points, right? So this is what our graph should look like. And now what we can do is we can talk about, let me erase this real quick, and then we can talk about the characteristics. And if you guys want to see the graph, so we're going to graph this function. I forgot what it was. The cube root of x plus 3 plus 2. So you go to y equals, you're going to click math. The fourth option brings up the cube root of x plus 3 plus 2. Go outside of the radical, put plus 2. Graph, that's what a graph looks like, except this is a little bit stretched out, so it might not look exactly the same. But if you click second and graph, you're going to go to the table, and you're going to see that we have the exact points that they have, right? So 5, 4 is one of the points right here. Oh, I erased my XY table, but 5, 4 is right here. 5, 4 is right here. Then we have negative 2, 3, negative 3, 2, which are those points right here. And then the last one was negative 11, 0. This one, I don't know why it doesn't. Okay, so you guys see at the end right here, where it says underneath the table, where it says y1 is equal to 4 point whatever. At the end, it says e minus 16. E minus 16 means move the decimal to the left 16 times. So that's, it just can't get any closer to 0 than than this number. So don't get confused by that. So always tap on it and look at the full number, but this should be a whole number. This should be 0. I don't know why it looks like that on the graphing calculator, but that's this point over here, right? So I'll show you guys how to use the graphing calculator on the next one just to help you write your XY table. But now we have the characteristics. So first we have the domain. So the domain is going to be, in this function, all real numbers, right? We have no limitations on our x values in a cube root function, right? Because we can take the cube root of positive numbers and negative numbers. So that means we can plug in any number. So our domain is going to be all real numbers. Next, the range. So this is an increasing interval right here, right? So on that increasing interval, we are going to, as our x values increase, our y values are increasing as well, right? So we're going to reach infinity for x values as well as for y values. And then over here we have a decreasing interval. So as x is decreasing, our y values are decreasing as well. So that means that we're going to have, we're going to reach negative infinity for x and also for our range. So that, or for our y values. So that means that our range is going to be also all real numbers. Next, we have our our endpoint, turning point. So we have a turning point, right? And we identified that first. That was negative 3, 2, which is right here. That's where our graph changes from decreasing to increasing. And next, we have our end behaviors. And so our end behavior as x is approaching infinity, right? So we want to know what's happening as our x value is increasing. And we also, this one is going to be as our x value is decreasing. So here we are actually approaching negative infinity, so we can write negative infinity here. Next we have, so here, let's start off with, as x is approaching infinity, our output, f of x or y values are also approaching infinity, right? And as x is approaching negative infinity, our y values are decreasing, so they're also approaching negative infinity. Next, we have increasing and decreasing intervals. And I don't want you guys to get confused on increasing and decreasing intervals. So increasing intervals, we have the segment where our graph is increasing as x is increasing, right? So our increasing interval would be from our turning point all the way in towards infinity, right? And so the increasing interval, it starts at where x is negative 3, and it increases all the way towards infinity. Now for this function right here, we don't have a decreasing interval. So the reason we don't have a decreasing interval, because a decreasing interval would be, and I know I called this a decreasing interval earlier, but it's actually not. I just meant like our y values are decreasing as our x values decrease. So when we're talking about increasing and decreasing intervals, this is referring to points where as our x value is increasing, our y values are increasing as well. That's what an increasing interval is. A decreasing interval is as our x values increase, our y values are decreasing as well. So we only have an increasing interval in this function, or in this graph, right? So here, as our x values are increasing, our y values are increasing as well. So a decreasing interval would mean as our x values are increasing, our y values are decreasing. We don't have anything like this, right? Because this right here is as our x values decrease, our y values decrease. But that's not a decreasing interval. Like I said, a decreasing interval is as x increases, y decreases. We don't have anything like that, so we don't have a decreasing interval in this graph. All right, so now for these next two, I'm going to show you guys how to graph these using the calculator. So you're going to look at this function right here. So, and you're going to take it into your calculator. You're going to click y equals, and then type in -2 times the cube root of x. So let's go to y equals, and to get the cube root again, you're going to click y equals, and you're going to click math. You can click the number 4, and it'll bring up the cube root. And we had, we had y equals -2 times the cube root of x, right? Yep, so negative 2 times the cube root of x. So now we can look at what the graph looks like. Okay, so since we have a negative in front of our radical, that means that we have a reflection across the x-axis. That's why this looks different from the other graph that we just did. So this is what our graph should look like. And you see the turning point is at the origin right here. That is our turning point. So we know that that's an origin. And we also know that because we don't have a h or a k value. So that means that they're both 0, 0. So our turning point would be at 0, 0. All right, so now what's going to really help us, if you click second and graph, we're going to go to the points, to the graph of this table. So this is going to help us find whole numbers that we can graph. So I'm going to write my XY table here, and I'm going to move the points from here. So when x is negative 8, output is 4. Those are whole numbers. Next whole number, negative 1, 2. Next whole number, 0, 0, and then 1, negative 2. 0, 0, 1, negative 2. And then 8, 4. That'll fit on our, or 8, negative 4. That will fit on our graph. All right, since, and you notice that since our turning point is at the origin, these numbers all just change signs, right? All right, so we can go ahead and graph these points. So we're at 0, 0. We're at negative 1, 2. We're at negative 8, 4. So we're right here. And next we're at 1, negative 2. So we're right here. And then we're at 8, negative 4. So we're right here. And you notice that these points are further away from each other than in our previous one. And that's because we have a vertical stretch of 2, right? So the only transformations in this function is a reflection across the x-axis and then a vertical stretch of 2. So let's go ahead and connect our points. And that's what our graph will look like. So now we can talk about the characteristics. So first, domain, all real numbers, right? We can plug in any x value in here. And since we have since here we have a decreasing interval and we have a point or a segment of our graph that our y values are increasing, our range is also going to be all real numbers. Then turning point is 0, 0. We identified at the beginning. Excuse me. Now, end behaviors as x is approaching infinity. So x is increasing. Our y values are decreasing, right? So that means that they are approaching negative infinity. Let me actually erase the arrows first. Next, as x is approaching negative infinity, right? So as our x values are decreasing, our y values, our output are increasing, right? So that means that as x is approaching negative infinity, f of x, or our output is approaching infinity. Next, we want to identify if we have an increasing interval, right? So, or a decreasing interval, and that means that as our x value, an increasing interval means that as our x values increase, our y values are increasing as well. So this segment, nope, this is as x increases, y decreases. And then this tells us this is as x decreases, y is increasing, right? So we don't have an increasing interval in this graph. We only have a decreasing interval, right? And it's actually decreasing all the way from negative infinity towards infinity, right? Because this segment right here, as x is increasing, our y values are decreasing, right? And then right here, as x is increasing in this segment, our y values are decreasing as well. So that means that our decreasing interval is from negative infinity all the way to positive infinity. And actually over here, that makes me think to number 11. We have an increasing interval right here, right? Because as x increases, our y values are increasing. And then in this segment, as our x values increase, our y values are increasing as well. So this is actually an increasing interval all the way from negative infinity to infinity as well. All right, and then the last one, number 13, you can go ahead and graph this on your calculator as well. So we're going to type in y equals, I'm going to type the 1/2 in parentheses, and it's 1/2 the cube root of x plus 1 minus 5. So math 4 cube root of x, I already forgot the numbers, plus 1 minus 5. All right, so this is our graph. It's going to look something like this. So this time the turning point is over here somewhere, and we're going to click second and graph so that we can see all the whole numbers, right? So we have 7, -4. I'm going to write my x, y table here. So we have 7, -4. Next we have 0, -4.5. Then we had 1, -5. Next we have -2, -5.5. And then -9, -6. Those are all the points that we can fit on our graph that are whole numbers, or at least close to whole numbers. And this time you'll notice that we have 1/2 as a, right? So when a is greater than 0 but less than 1, we have a vertical compression, right? So all the points are going to be a lot closer to each other in terms of like the y-axis. So let's graph them. This one's going to be a little hard to connect the dots, but so we're at -9, -6. So we're right here. We have -2, -5.5. 5.5 is going to be right around here. Next we have 1, -5. And this is our turning point right here, right? At 1, -5. Next we have 0. Oh, this was supposed to be -1, -5. Not +1. So -1, -5 is going to be right here. Next we have 0, 4, and -4.5. Which is right around here. And then we have 7, -4. So that point's right here. So I'm going to zoom in so I can connect them a little bit better. So it's a little hard to see it, but this is the turning point right here. So our turning point is right here at -1, -5. Our domain and our range, again, are going to be all real numbers for both of them. Then we have as x is approaching infinity, so as our x values are increasing, our y values are increasing as well, right? So as x approaches infinity, our output approaches infinity. Next, as x is approaching negative infinity, so as our x values are decreasing, our y values are decreasing as well, right? So that means that as x is approaching negative infinity, our output is also approaching negative infinity. Next, we want to identify if we have an increasing interval, or a decreasing interval. So as x is increasing, y is increasing here as well, right? So that's an increasing interval. This is an increasing interval. Next, over here, as x is increasing, our y values are starting to increase too, right? It went from -6 to -5.5 to -5. So it's a slight increase, but it's still increasing. So this is also an increasing interval. So that means that we only have an increasing interval, and it's from negative infinity all the way to positive infinity. We have no decreasing interval. So that's it for graphing radicals. When you finish this worksheet, go ahead and start working on the next worksheet, which is solving radical functions. If the sub has not given it to you, ask them. If you are at home, I'm going to be linking that video and that worksheet later today.